So good evening to one and all joining us today. We have Gavin sir. He's specialist in database implementation, logical programming, functional programming, type theory, logic, and anything related to it. So welcome to the show, sir. And
Well, thank
I'm
you very much.
uh, so please start.
Can you see my screen?
Yes.
Great. Okay, so I'm Gavin Mendel-Gleason. I'm the CTO of TerminusDB, and thanks for the introduction you gave me there. So what I'm going to talk about today is document graphs for the data mesh. So I work implementing databases, and I'm specifically very interested in trying to improve collaboration in database management systems. And so I want to talk about how we can leverage connections to create what we call data products. So there's a notion that's being promoted called data mesh. And the idea is essentially that collaboration with data is really important. And so in order to collaborate, what we should be looking at is not just having data resources, but really designing data products. And that means that they're consumable easily at the point of the consumer. So and I'll get into this in a little bit more detail. So first, what is a data mesh? Okay, so the main idea behind data mesh is that we structure the production of data using a domain focus. So if we want to create some sort of data product, we want to have tools that allow us to get together the experts in some domain along with some technical experts and to produce a data resource that then is consumable and that the domain experts can review, can help to make as good as possible. So data is a product in this view, and that means that not only are we trying to make it easily consumable, but we may also be using it to build up other products. So in this example, we have Campbell's soup. There's mushrooms that are in that soup. Those mushrooms themselves are a product that is used to produce another product. So up the supply chain, up the stream, we need other things to be produced that are then used later. And this is often the case with data. It's very common that data products are consumed by other creators of new data products that assemble the information in different ways. They extract elements of the information, they cross-correlate, or they produce subsequent results on the basis of the input data. Now, part of the other idea behind data mesh is to try to make the data as self-service as possible. So this is an example of a marketplace where you might go in and you just pick what you need, put it together, and of course you might be thinking you're going to make your own output product. In this case, maybe you're making spaghetti or something along those lines. You want a little bit of wine, you want a little bit of tomato sauce, and maybe some herbs, and you assemble it together yourself at home. But we want each of these different commodities to be readily usable as it is without having to do too much labor. So another aspect is governance. So governance means that you have some way of communicating the meaning of the various different elements that are in that. So you want to have the data cataloged in such a way that you understand what's in the data, that you have understanding of the semantics of the data, such that you can put it together into more meaningful elements at the top. So some aspects of data governance are what kinds of words we're going to call things. What is our vocabulary going to be? If you want interoperability, you have to have some way of discovering that. So we call this domain sharding, where you have the ability for domain experts to define the words in an area that they want to use, and then you can assemble them into larger components, and that gives us a large scalability, so you can scale up. Okay, so now if you're a developer, of course, you're going to in the modern age be familiar with JSON. So dictionaries, associative arrays, these sorts of objects are now ubiquitous. They're used both as serializations, and there's data structures that are used to manipulate them quickly and easily in many different programming languages, from JavaScript, Python, but many others as well, including Java and others. They're very useful in the sense that they're a little bit more human readable than some previous data structures were. They're easily serializable, so you can spit them out into files or communicate them via RESTful APIs or other APIs, and they have some flexibility about the way that data is presented. So in this case, we have John Drake, who's 35, has a biography, and then some address, his street address, along with the city and country. And you actually, even without a data catalog, it's pretty explainable, and it doesn't take that long to read. Whereas in many sort of past formats, such as XML, it would be relatively difficult to parse this without some additional information. And so that has made it very it has made it very common for programmers to use. So TerminusDB tries to take these ideas and bring them together. So what we want to do is we want to help people to make data products for real data, and we want them to be able to do so using self-serve data. And so we want to use JSON as a format that we can use for interchange, and also to catalog the information in the first place. So here we have an example of what it takes to add a document to TerminusDB. So the first thing we do is we define a schema. In this case, we're going to create a new class called a player. We're going to define a key. So that key is going to help us to say how to represent a player. In this case, we say that the key is lexical, and it has a field's name. And then we have a name, and we say that this name has to be a string. And then we have a position, and we're going to say that this position is also a string. In this case, I'll just explain very quickly how this works. So we have here on the right-hand side, we have a list of objects, and these are the actual objects that represent the individual players. So we say that it's of type player. We give it a name, George, and a position, center back. We have a list of objects here, Doug, fullback, Karen, center forward. And then we can just use our TerminusDB client, and we can add those objects to TerminusDB. Now, in this case, we didn't specify the IDs for any of these players. The IDs will be constructed automatically based on the key. So we know that we can only, because our key is a lexical type key and it has the field name, we will construct an ID for the player George called player/George. And that will make sure that we only ever have one of those at a time. So that identifier has to be carefully chosen so that we can represent our objects uniquely in the database. Now our documents, because they're uniquely represented in the database, we can also have links between them. And so here we are going to add to our schema a new document called a team. And again, we're going to use a lexical type key to represent the name of the team. And the team itself will have a name, and it can have a set of players. So a set is a collection of players that has no order and no duplication. So it can only represent a player once in its set, or it doesn't make sense to ask how many times it's in the set. But you can say that it definitely is in the set or not in the set. And the things pointed to by players can only be a player object. So if we wanted to create some teams, we can do it using a JSON object. And we see on the right-hand side, we have a team. It's a Wildcats. We're going to submit it. And we're saying that the Wildcats have the player Doug and the player Karen. And these are the unique identifiers for Doug and Karen, which we added previously, and you can see that it's based on their name because it's a lexical type key. And there's many different types of key. We can have compound keys. They can use any number of fields. They can even have fields that are themselves objects, and then they use some information about the sub-objects within them. We can have random, and we can have hashes. And so these various different identifiers are used in different circumstances, depending. So our documents, because they can have links, we can actually construct graphs. And our graphs are genuine graphs. They allow us to point to any object. So in this case, we have the person Joe has a friend, the person Jill, who has the friend Joe again. So Joe is pointed backwards. It's backlink. So they're actually friends of each other because they point back and forth at each other, instead of just having a single relationship link, which is bidirectional. So this we also in TerminusDB have a query language that allows you to ask questions of the graph. So you can ask for connections that are any number of links away. You can ask for all the connections that follow certain paths. So it is, in fact, a graph database. And all of the information is at base stored in a graph, even though we communicate to it using documents. So we also have two different sorts of linking that we allow. So one is something that we think of as static linking, and that means that all of the objects that you refer to are actually in the database or the data that you're constructing, the data product that you're constructing. And another is dynamic linking. And in this case, you might refer to external objects that have some unique identifier. And so because in TerminusDB, all objects have unique identifiers, it's possible to refer to other data products and identifiers in those, which allows us to do this sort of domain sharding, where you can have different domain data products that interlink or refer to each other. Now, these identifiers here are a shorthand. They actually, these are all at a relative link. So there's a full URI that precedes this, and that's defined by which data collection you're in. So the full URI allows us to have actually these things qualified as dependent on the actual data product that you're using. And using that, we can then have safety in producing interlinking data products. So you might have a domain team that's responsible for creating finance data product, but you also might want to use information from HR and sales in order to perhaps put together some list of which meetings you're going to be at. Now that would have to, like if you wanted to go to a conference or something, say, you'd have to bring in information from HR, you'd have to know something from sales about, what you're trying to sell, and then you might need to know about finance as well. And you could create some kind of calendar data product that synced information from all three of those. So TerminusDB is also used for collaboration. And so because we're trying to create distributed and interconnected data products, we really believe in the idea of immutability. So immutability means that whenever you change something, instead of changing the original thing, you create a new layer, and then you refer back to the original thing. And in this way, we are able to perform a lot of operations that are difficult with standard databases. So one of these is just the ability to time travel. So if you see this time travel on a branch dialog, you could just click on a time travel point. That takes you back to a commit, what we call a commit that happened in the past. So every time you do an update, a transaction on the database, in fact, what you're doing is adding a new commit, and then those commits are available for query, or you can time travel to them, you can roll back to them, and you can branch from them. So you could go back to some previous time in the past and you could branch, or you could decide you need to do an experiment and you could make a branch now. start updating that branch, look at the impact of that branch, and then if you like it, maybe merge it back into main. So branches have their own history behind them. So you might switch to a new branch, and then it has all the history, all of the people who updated it. In this case, you can see it could be an update that's caused by a programmatic source. So here we have commit via Python client. So you could have automated processes or scripts that do the updating, and we record all of the information about who updated what was updated, and allow you to time travel. So this time traveling is not just in the branch that you're currently in, but really you can move to any commit anywhere in any of the branches in history. And that makes a very flexible way of doing data updates, allowing us to do experiments, and then also doing curation. So many of you might know about curation workflows in Git. So Git allows us to update source code in a branch, and then once we've identified that the by hand looked through the code, made sure it was correct, we might have a linter run over it. The linter would do some sort of automatic traversal, decide that it's correct, at which point then you can merge it back into main. Now in data, we still are sort of in the dark ages, and we haven't got to the point where we do this for our production data, which seems kind of crazy, but that such as it is at the moment. So what we would like to see is more of this software, CI/CD, continuous integration, continuous deployment approach, being used in data itself, where it's really critical that data resources are only updated for production or sharing when they've already been checked, either by human operators, machine operators, or a combination of the two. So in order to do that kind of collaboration, you want rebase type operations, merge type operations, and these allow you to develop feature branches and then place them back onto master after you have successfully tested that they are correct. So we think that document graphs are going to enable this kind of mesh approach to data production, to creating real data products. We want to see more collaboration. So revision control is really at the heart of collaboration. It's what made Git capable of really having a multi-master approach, which was distributed over the entire world, where people can make updates locally and then share them in a global space of commits. And it allows the kinds of CI/CD pathways that I described previously, where you have continuous integration, continuous deployment, you have human and computers working together to try to ensure the quality of data. You can then also have safety. So if something is damaged, you actually pollute the repository, it's very easy to take a Terminus DB that has become polluted with some kind of automatically added data, for instance, and just roll back to a previous version. So rollback is almost an instantaneous operation. You assign the commit that you want to go back to, and presto, you're there. Or you can revert, so you can create a new commit that goes on top that undoes the changes. And that way you don't lose any of the history in going back, but you can remember that that incorrect update was made, but advance back to the original state. We really believe in knowledge graphs as well. So we've tried to make these documents so that they can connect to each other in a meaningful way, so that they can really be traversed like a graph, because graphs are really at the heart of many of our data modeling problems. And it's a very general data structure. As an abstract data structure, basically everything can be fitted to a graph in some way. So it's quite effective in that way. And then the commit graph really is enabling of this idea of versioning. So let me switch quickly to TerminusDB itself. So this is what this is our SaaS product, TerminusDB and TerminusDB is an open source product, so anyone can download it. You can get a Docker of it, run it on your own computer, try it out, and see what you think. But it's also a SaaS product, so we have free accounts for developers. You can come on to TerminusX, try it out, see what you think there as well. And on TerminusX, we have this dashboard. And the dashboard allows you to look at some of your data products and get a bird's eye view. So for instance, here on the left, I have a list of different experiments that I've been running. One of them is the Seshat experiment. You have a series of the commits that have been made on it. And you can see the recent commit activity that was made on top of it. If I look at the schema, we get an overview of the schema as it currently exists. Now, it's a very complicated schema in this case, so it can be kind of daunting. Many schemas are less complex than this, but it carries a lot of information about things like all human polities and human history. So we want to store lots of interesting information like the degree of centralization of the city-state or country, which is talking about how whether they had small vessels, what kind of scientific literature they had. And so you get this idea of what it looks like to have a data product that describes historical civilizations. And you can also see everything in a JSON view, and this is maybe the way you want to interact with it programmatically. And this JSON view just gives you, it makes it easier to go back and forth between the programmatic way of looking at something and the visualization approach. We also, you can see each of the individual objects that exist in the database as one of the classes that's defined. So for instance, we have this, let me actually look at a polity example. So a polity is a city-state or a state or, sorry about that, one sec, too clicky. Oh, I'll just look at a nuclear data product instead, actually, because I have this open. So, so here I have a nuclear power plant, an example of one of the objects that might be in a nuclear data product. If I look at the JSON document, this is one of the objects that exists as a nuclear power plant object in the store. And you see it can have sub-objects inside of it. And here in this particular case, I'm looking at the capacity numbers as a unit in megawatts electric for a particular data or a particular nuclear power plant. And then we can have this view of it where you actually see sort of visualizations of the data that's in there. In this case, you can see exactly where the location is. You can see what year it was commissioned, etc. And then we have an edit view, which allows you to edit these various different fields, and you can submit it. So the edit view and the viewing of the form itself is all part of our UI SDK. So we have a software development kit that allows you to edit these objects. And here it's being shown in TerminusX, but you can use the UI SDK in other applications as well. So we want to try to modularize this as much as possible so that you can use it in your own application. And the UI SDK is also open source. You can download it, try it out, and see what you think. So let me just briefly go back to the nuclear schema. It's slightly simpler than the Seshat one, so we can give a little bit of a look. So here we have an abstract class called a reactor, and then we have research reactors, experimental reactors, and power reactors, which are all the concrete classes. And so those concrete classes might have documents that are assigned to them. So that just gives you a brief idea of how that works. So to see what it looks like in an actual application, let me quickly look at a product that we're working on right now. So this is called the Critical Asset Management System. And it is a system that's designed to track critical assets for climate resilience. So in this case, we have some examples on the island of Dominica. And what we're trying to do is track how these different assets depend on each other. So if I click on the Trafalgar hydropower plant, then I can see the information about that asset on the right there. I can also ask for, I can look at the assets directly here. Sorry if my login has expired. I have to log in again. One moment. There we go. Okay, so here I have the Trafalgar hydropower plant. If I zoom in here, after having clicked on it, I can see that there are critical links and non-critical links that are associated with it. Now, the critical links are downstream dependencies. So these other assets depend on the Trafalgar hydropower plant functioning. When the Trafalgar hydropower plant falls over, then these other assets are no longer usable either. So this gives us some kind of visibility of the dependencies that we have between assets. And we can also look at the failure path. So we can look at multi-hop paths along these different links. And this is an example of how a graph database gives you easy access to graph-like information. So we can see all of the critical links all the way down from the Trafalgar hydropower plant. Now, if this should fall over, then we might want to know who to contact. And so there's information about the contact there so that we can tell them that they need to fix it. So all of the assets are here listed in a table. And if you go to any of the individual assets, you just get our UI SDK editing software. So you can see that right now it's not in edit mode, but if you put it into edit mode, you can go in, you can set different dates on things, you can add asset history. So if you did some maintenance, you could add it there. And then you could add owners if you want to change which owner is associated with a given data product. And we also maintain the links between the various objects here, similarly using this, this UI SDK. Owners as well. So all of these different objects are immediately editable using the UI SDK because we have information in a schema about what those things mean, what types they are, and what can be submitted in them. We can also use this to try to determine which assets are liable to be susceptible to different kinds of natural disasters. So in this case, I set natural disaster of hurricanes, typhoons, or cyclones. And here we can see that the Trafalgar hydropower plant would be susceptible. But if I turn it down to a size 2, then it's really just the airport authority that would be susceptible to the hurricane. So this gives you a kind of modeling capability. And again, these are just queries that we use against our Terminus DB database. So with that, I think this gives you an idea of, in practice, how this kind of approach can be used together with the graph, the knowledge graph approach, the UI SDK, which allows us to edit the objects. In the background, we've kept all of the history of all the operations that take place. So if people update the assets, we're easily able to see who did the update, at what time it took place. We're able to roll back if there's any kind of problem with that. And we can also synchronize information from various different organizations and bring it all using merge into the same database. So hopefully that gives you an idea of what Terminus DB is, how you can use it, about Terminus X, and maybe gives you some interest in going to see it. So with that, I think I can turn over to questions if anybody has any questions that they'd like answered.
Thank you, sir, for the informative session. I not only learned a lot, but truest enjoyed it. I hope our viewers did it too. Now let us move on to the
Sorry, what was the last thing you said?
So the Q&A session.
Yeah, so we can do a QA session if you like. Is that okay?
So we don't seem to have any questions in the comment. Is there any advice you would like to give to our upcoming programmers?
Yeah, so if you want to get started with Terminus DB, if you have a Python client or if you have Python or JavaScript experience, I would recommend getting our Python client or JavaScript client and going through our Getting Started guide. The Getting Started guide should show you how to create a data product quickly, how to get started putting information into the database, how to get it out, and then for the UI SDK, there's a demonstration UI SDK in the GitHub Terminus DB repository. So you can try it out and see. It allows you to edit the style information for the UI that you're building and has some examples to play with.
So we have another question. How can we integrate Terminus if one have already have a DB in their project?
So if you already have a database, we have to, if it's a MongoDB, you could probably create a schema which allows you to import those very directly into TerminusDB. If it's using some relational database management system, we don't have a connector that automatically translates because we are based on sort of JSON type structures. But it's not too difficult to write a translator that would pull out the objects you have of interest. So row-based objects will obviously just be flat JSON objects and could be done quite easily. And then links between, usually you want to point at the object itself, but usually you have some sort of ID in a database on one of the columns, perhaps like a user ID for a user column. And then you would just make that your ID for the object, and then you could link them together without too much difficulty.
Thank you, sir. With that, we end today's session. Thank you for being here with us today, sir. It was an honor. I was Apurva Puthari, your host, and this was the third Hack Talk by Equinox Trinity College Dublin. See you again tomorrow. Thank you,
Great, thank
sir.
you.